So just a quick video on how to modify a cassette player or possibly a recorder to be interfaced with the Koma electronic Field Kit DC interface. I posted a video showing this one in use and it got a lot of interest, and I'm going to be modifying some for sale, but I also wanted to share the information. It's pretty straightforward, but a couple tips might help those who have never done something like this before. Basically what you're going to be doing is wiring the motor that drives the cassette player directly into this driver, so that this is going to now power that motor. You still need to have batteries to power the amplifier. Pardon my neighbors shooting right now. I live in the very rural area, so there's a lot of guns around. So you still need to power the amplifier and other parts of the cassette player with the batteries, but the motor will now be powered by the Koma. And like I said, it's pretty straightforward. And this one I've already modified and labeled. So this new 1/8 inch or 3.5 millimeter jack is specifically for powering that. And I built a special cable. Let's see if I can find it here real quick. It has a barrel jack on one end and an 1/8 inch jack on the other side, and I've labeled it so I know what it goes to. Polarity is center negative, and make sure that you have that correct. Otherwise the tape player will play backwards. The motor will turn backwards and you could possibly damage the tape. But it's pretty easy to do and check before you actually play anything. But to get to the tape player specifically, this assumes that your tape player works. So that would be the first thing that is relatively important, that actually have a working tape player. And because otherwise you're going to have another job of trying to fix it, which is a whole nother thing to do. This one I've already kind of started, so I stopped what I was doing, and now I'm going back to try to do this video. So here I've already removed the 3 screws that we're holding on the back. This has a separate battery carrier that I've removed, and that is kind of like a shuttle that goes inside of here that holds it. It's very unusual. It takes 4 AA batteries. And of course I've removed the battery cover. So once those 3 screws, which are here, have been removed, you can take the back off. And this would be a good point to say that everyone pretty much has a camera or a cell phone. As you go along, take pictures to be sure that you put everything back correctly. It's very easy to mislabel or misplace a screw or not understand where they go. If I was going to be working on this any longer than an hour or two, I would put these in a baggie and put them away. I should probably do it anyway, or in a little cup or somewhere that won't get them knocked onto the floor. Here's the 3.5 millimeter jack that I'm going to be using. You could also use a barrel power jack, but as you can see, they're much larger in diameter and will require a bigger area inside of the case. These older Sanyos I'm coming to favor because they have such a large amount of space inside for places in order to put your jack. There are some tape players that I have opened that it is almost impossible to find a spot in order to put a jack. You would actually have to wire the jack outside of it or create an expansion box. I prefer ones where everything is all built in and you don't have another unit attached to it. So that's the way I like to do it, but I know a lot of people have done that where they glue a box onto the back of the player, and that's where all the maybe speed control or CVN, actual CV motor control is in. In this case, like I said, we're doing the DC power for the motor. So here we go, taking the back off. This one was relatively easy, just had 3 screws, and they're very nice machine screws that actually go into metal posts on the inside. So anyway, here's that. Take that aside. Again, it can be a good place to store your hardware as you go along. Put all those things over there. On the inside, there's more screws that will need to be removed, but I guess maybe a close-up now will be helpful. Here's the motor, and there's the belt. And on this one, I'm trying to look through my camera here. I don't know how well it's going to be visible on there, but there's actually a legend on the circuit board that says motor positive and motor negative. And that's that blue wire and the red wire right there. The other two are going to the positive and negative of the battery terminals. So those two are the ones that are going to be removed, and we're going to mount them onto the jack over on the side. Now here's where you actually, before you get going too far, is good to explore the case and see where it's possible to put the jack. In this particular case, this circuit board is impeding access to any of the places. I see a good spot here, I see a good spot here, I see a good spot here. The PCB is in the way, so that needs to be removed. And I've already removed this once. I'm going to do it again. I had put it back for clarity. But here's a screw that is holding the PCB in place. And I know for a fact that I've already done this once. This screw is longer than the other one, and it belongs with this shield. So I'm going to put it on it in order to keep it together. I might take a picture if I didn't have that. There's a couple other screws here, but I know for a fact from before that this is the one that mounts it to a post. So I'm going to take that one off, place it over here, and that will allow me to at least partially remove the PCB. Now the wires here, here, and there were wires here, these brown wires, which I've already desoldered, were placed on the circuit board after it had been put in place during assembly. So in order to get this off, you would need to remove some or all of them. And I found that these two, which go to a power on switch on the inside of the player, were enough to grant me access to the inside. So now, being careful not to bend or damage the wires too much, I have access to the entire inside, and I also have access to the belts. This particular one has a belt from the motor to the pinch roller, and one from the pinch roller to the spindle, the take-up spindle, and I've replaced both of those already. I highly recommend going on eBay and ordering a pack. Usually that's $2, somewhere around that, of replacement belts. They're not the best quality belts, but a new, not that great quality belt is a lot of times better than the old belts that are in, especially one that is this aged. These ones actually were not that bad, and this was completely operable in the state that I got it. So there we are. So now you can see that I've got lots of areas to place the jack. I can put it up here, I can put it over here. The other thing to keep in mind is to check for clearance with any parts of the circuit board, any capacitors or other things that are sticking up in the way. I'm going to pause the video here and hopefully be able to edit in the next step, but I'm going to mark out where I'm going to place the jack, and I'm going to drill the hole for it. Okay, it's an hour and a half later, and I finally have the jack installed. I had to change jacks because this one was too deep for the area that I had chosen, and so luckily I had another one that was shorter in depth. This one is quite deep, so I had to find a different jack. I had to whittle out the hole that I had drilled, despite placing it as well as I thought I had. It was still off by a bit, and so I used a step drill at first. These are very nice. You have to pay attention to anything that might be in the way as you start to drill into the enclosure, especially if you have the board still in place. And then also I'll be very careful as you move into using a standard drill bit. Plastic will tend to grab and pull the bit into and potentially damage components inside. I may have done that. My first attempt to drill in it, it pulled in quite strongly, and I hit something, and hopefully I didn't damage it. I won't know until I get it partially assembled and start to test it. But here's where I ended up putting the jack. I've got the wires pre-installed. I put a piece of electrical tape around it because it butts against a piece of metal down at the bottom. I want to make sure that it doesn't short out against it. There's a little bit of the contact exposed down there. If I was doing this again, I would probably do it in this area up here. There's quite a bit of room and very few components in the area up here, but that would cause an issue in that there would be an 1/8 inch headphone jack right next to an 1/8 inch CV in jack, and the confusion might lead to damage. So that's something else to consider when you're laying things out. But I'm ready to resolder these two and to bring these two leads over and solder them to the wires over here, which I will be removing and soldering to these and sleeving them with heat shrink tubing, and then dressing them and putting it all back together. And I'll show that once I'm done. Okay, everything is buttoned up. Well, mostly the back is not on. I'm using gravity to hold everything together. I have not done the heat shrink on the tubing yet, just to be sure that I did everything correctly. And we're going to do a quick test. So I've got the power from the DC driver here connected to my new jack, the headphone out into channel 2 right now, and everything else turned down, that with moderate gain, and the volume turned all the way up. You can hear that I've already got the play button engaged. That's relatively important to have that engaged first before you start moving things, because otherwise, without the drag of the tape, things tend to get out of hand really fast. I'm not using any control or trigger on the DC right now. I just have it in pulse width modulation, and I started at 0. That is also really important when you're starting this out, until you've figured out what this can take as far as voltage goes. The intensity knob I've measured. It's the Koma instruction manual says it goes up to 9 volts, and the intensity changes the voltage that is, and I believe also current that is driving this. So you don't want to start with it all the way up, because then it's going to put 9 volts right onto your tiny little motor and it's going to burn it out. So I'm going to start turning it up and starting to see a little glow. Nothing's driving yet. Probably see that the tape is turning very slowly, and as I turn it up, this is a tape of Gregorian chants, so you can see we're faster at this point than normal feedback. And down to slow. You can control this with the LFO. See, I'm on square wave. So the tape rotation speed is being pulsed with that. When I turn the intensity down, it won't be as much of a pulse. And if I go all the way down and then switch over to pulse, I get a similar effect, but it feels slightly different to me, especially if we go to triangle wave. And I've also been able to control the driver with the analog switch, or the analog in and with the switch in. Let's see if I can find my jerry rig switch here real quick. This is a very simple single pulse switch. So if I turn this down, again, you want to turn this down to almost nothing whenever you're switching from one form to another. I'm going to put this into the triangle waveform. I have it set to long and at full length. And as I hit this, it should turn up the intensity a little bit, provide that's an inverted triangle ramp with every press. And that will, I think, also work with pulse. If you do the inverted, it will play, I believe, that's obviously a different triangle form. If we go to the square, and I turn down the intensity, went to square, if I go to the gate, it will shut it off. So anyway, lots of possibilities. Now that I know that this all works great, I will button it up and probably put it up for sale on the Facebook Koma page. So if you're looking for one of these, contact me there. Or if you have any other questions, please try to contact me at the Facebook Koma Electronics Field Kit page, and I'll be glad to try to answer what I can. But hopefully this is enough to get you going and have fun. And just one last little note about the wiring. So I did end up heating up the heat shrink tubing to protect those contacts from any damage or from shorting out on anything else. I've routed the wires down here and up through the original tab in the circuit board that they came up from, but now they're going off in this direction, and I may use a dab of hot glue here to keep it in place about there so that it doesn't interfere with these other wires, and that I can close everything up. And then once I do, I will probably put on this one a nice label like this one to indicate what that jack is for should come down the line. Someone else get a hold of this and not understand what that's for. So that's it.